so that I can repeat things if necessary.
Cool. I guess I would just open my camera. Hi guys, this is Chris from DoraHacks. Welcome to the very first workshop for Akash-a-thon. I'm not sure if I pronounced it right, but it's actually the very first time that for DoraHacks to support Akash Hackathon in our history. It's definitely a very exciting moment for us. Akash is one of the most important network and infrastructure for the whole Cosmos and Web3 ecosystems. So it's definitely a very exciting things for us. And for this hackathon, we just kick off. It have a little bit more than a month for submissions, and it's purely virtual. So basically, wherever you are as a developer, if you have any ideas, any interesting things that want to be built on top of the Akash, you are more than welcome to join anytime. And it also has a 50,000 USD prize pool. If that can interest you more. So today we are also very happy to have Sean from Secret Network to join us as the speaker of this workshop. He will cover the workshop on accessing verifiable randomness. And Sean, he is the developer relation engineers from the Secret Network Foundations. I believe he can introduce himself later and start the workshop. So Sean, are you ready?
I'm ready. Let me just turn my video on for 1 sec so you guys can see I am not an AI.
That's awesome.
What's up, everybody? Super excited to have everybody here. And I also didn't realize this is like one of the first times DoraHacks is doing this. So very cool that we're all pioneers in the cosmos today. All right, I'm just going to share my screen so that we can jump into some slides very quickly. Let me know if you guys are seeing this.
Yep, we can see it.
Awesome.
You too.
And I think I shared the slides link with you guys on Telegram. So if you can just share that with the chat, whether it's on YouTube or Zoom or however is best for everyone to receive this, because we have a lot of resource links in these slides. So I want to make sure everybody has access to this. All right. Hello, everybody. At any moment, if I cut out, just let me know so I'm not talking into the void. I'm super excited to be here today, speaking about on-chain verifiable randomness for Secret Network and the Akash-a-thon. My name is Sean Conrad, and you can follow me on Twitter at SecretSeanRad. So I just want to give you all a little bit of a background on how I found my way into the cosmos, because I think, you know, a lot of us, if you enter Web3, it's usually not maybe in the cosmos, it might be from another trajectory. And I had humble beginnings, just reading the Bitcoin white paper, you know, that 8-page thing of glory, and having my mind blown, and I couldn't stop thinking about it. And from there, basically, I just started to think like, you know, what is the fastest way I could dive into the world of Web3? And this is about 2 years ago. And so everything at the time was Ethereum was what I was seeing. And so my first experience with Web3 was learning Solidity and doing ETH New York. I'm based in New York City. And from there, I kind of just got the Web3 bug. But what happened was that my team, we won a hackathon prize at ETH New York, and we wanted to make another hackathon project. So we decided to build like a ZK DAO for HackFS, which was another month-long hackathon that was remote. And in that process, it was my first time diving into privacy technology. And, you know, we were creating this DAO with ZK verification. And basically, I just found the whole process very limiting for users. Like, we made it, it worked, but I didn't think that anybody would actually use it. And what I'm excited about with Web3 is figuring out ways to lower the barrier to entry for users. And so I thought there must be a better way. And I had this idea kind of cooking in the background for a while, which is that I wanted to make a business card application because I move all the time in New York City and people are always, my grandma would send mail to my previous address, not knowing that my address had changed. And so I was like, what if I could make something in Web3 where every time my address updates, it updates for everybody that has access to it. That was the idea, right? This Web3 business card. But like, obviously you don't want to dox yourself on a public blockchain. And I also had a really not great experience with ZK tech. And so this is what led me to start just Googling into the rabbit hole of Secret Network, which is pretty much the privacy hub of the cosmos. It's a place where we have customizable privacy and programmable privacy with smart contracts on Secret Network. So I ended up building this business card application and had an incredible experience doing that, and then just fell face forward into the cosmos. And what's exciting about Secret Network is that rather than using ZKs, the way the privacy tech is built, it's using these things called a trusted execution environment, which is basically just like a black box for data processing. So everything that's happening on these nodes that are verifying these transactions, it's all happening in this TEE environment. So none of that information actually exists on chain, or it exists on chain, but it's all veiled, it's encrypted. And so this is really exciting because it basically just opens up all these doors to customizable privacy with smart contracts that I hadn't seen when I was around Ethereum. And what I want to teach about today is something that's, I think is extremely exciting, which is that about maybe a month ago, 2 months ago, Secret Network introduced on-chain verifiable randomness. And the way it's implemented, it's extremely elegant. It all comes from the environment variable. So I want to just kind of just show you just a quick demo of like what's possible with this on-chain randomness. Because like if you're coming from Ethereum, right, there's Chainlink, Oracle, but in the Cosmos, we don't have that many options right now. And so this is an extremely simple, intuitive design for anyone's smart contracts. You can IBC to it. I just created also an IBC demo between Juno and Secret, which I'll make sure to link to so you have those resources. But what I'm excited about is the idea of developers in this Akash-a-thon using verifiable randomness on Secret Network to figure out interesting ways to kind of just bring their applications to the next level. So Secret Network was at ETH New York, at ETH Paris a few weeks ago. And for that, I just built this verifiable randomness demo, which, oh yeah, check this out, guys, right? Isn't this cool? I built this in Spline. I know you all think this is cool. All right, so the way this works, this is just kind of just a test suite to just show what this is, but like you can just pick a number between 1 and a million, and then it will return a random number between 1 and a million. Just show you, so this is my Kepler wallet, right? This is all happening on Secret Testnet. I approved the transaction, and then it should return back a number between 1 and 500 because that was the number I selected. All right, please ignore this terrible color scheme. It was just a demo. So this is the actual like encoded string that is returned from the randomness contract. And the number that we had between 1 and 500 was 13. And if you want to see that source code, you can view it all right here in this GitHub repository. But I just want to walk everybody here through the Akash-a-thon secret VRF track very quickly, which is, so there's 3 prizes. There's a first place, second place, and third place. And really what the hackathon track entails is just using secret VRF in your application. So if you scroll all the way down, this is all the tracks that are available for the Akash-a-thon. And if you go all the way to the bottom, we'll see the Secret Network verifiable randomness track. And what we're really excited about is if a developer were to find a way to IBC a verifiable random number from Secret to Akash. Because this is like brand new tech, and I just did this on Juno for the first time as a proof of concept on Juno testnet. And now what I would love to see is if somebody who's listening to this, somebody who works on this track was able to do this for Akash. And I think you can do that with inter-contract accounts from what I was looking at with the Akash tech stack. But basically, all of the resources you could possibly need to do this, I think, are right here. We have our getting started documentation, which shows you how to upload and instantiate on testnet. We have privacy design possibilities for developers. So this is just like different ways of thinking about how you might design your privacy if you're working with a secret smart contract. That's definitely good food for thought. And I also have this IBC documentation. So this is showing how to access random numbers from secret to Juno. And it also lays out all of the architecture. We actually work with 3 smart contracts on this. There's 2 Juno smart contracts and 1 secret smart contract. So you might look at this if you're thinking about how to implement this on Akash. What else? And then lastly, oh yes, the secret network developer Discord channel. If anyone has any questions at any point and they're like specific to working with secret, just pop into here and ask your questions in the developer Discord channel, because secret developers are more than happy to answer your questions and help you troubleshoot. So I don't want any barriers to entry to understanding the secret tech stack to inhibit you from your developer journey. Does anybody have any questions before I do a really quick demo and dive into the code? No questions?
Yeah, I think we are all good right now.
All good. All right, awesome. And does everybody in the chat have access to this slideshow, so they have these resources? Okay, I'm gonna stop.
I believe so, but if not, we can definitely add all of the links on the Hackathon page later.
Amazing. All right. So I'm just gonna share. Does everybody see my code?
Yep.
Yep.
Incredible. Okay. So this is just a basic CosmWasm smart contract. I think what this is like maybe even it's like the Juno counter smart contract. So it's literally just a CosmWasm smart contract that stores a state of like the owner's address of the contract, and then also the count, the current count. And then what the contract does is allows you to increase the count by 1. And what I'm showing you is just like how easily you could implement randomness on secret network. And so what I did is I just took that counter contract and I literally just changed like the count variable to a flip variable. And what we're going to look at here is just the idea of using verifiable randomness on chain to create a coin flip smart contract. So we're going to receive this random number from the secret smart contract. And then what we're going to do is use a modulo to just make it either 0 or 1, representing heads or tails. So if you've never looked at a CosmWasm smart contract before, I'll just kind of give you a really quick run through. This is our state. This is the storage of where everything is actually being stored in our smart contract. And again, all that we're storing in this state struct is just the flip variable and the owner of the smart contract. And if you see here, these are like very standard CosmWasm imports. So nothing out of the blue. Our message file, this is where this is what the contract actually does. This is the exciting part, right? And so all we want to do with the smart contract is have a coin flip, right? Is we want to return a random number from the secret network testnet and then use that to have either 0 or 1. So we have a starting instantiate message of a flip. And then the only execution message we have is this coin flip. And then we're able to query this coin flip. And the response that is returned is just that number. Okay. So I left only 2 things for us to implement in this smart contract, which is 1, just this execute message. So let's see. And my apologies if this is like a recap for anyone who's like an experienced smart contract developer, but I kind of wanted to just do this from the perspective of like, if you're completely brand new to the Cosmos and you've never even seen CosmWasm before, what this would look like. So all that we're doing is just accessing this flip message from our message.rs file. And then we're going to have this a function where we actually receive the random number from the secret network blockchain, and then use that to create 0 or 1 for our heads or tails. And the incredible thing about this is another reason why I wanted to show this, is all that we need to access this is our mutable depths and our environment. Because the way this actually works on secret is that when this random number, it's coming from this environment variable. Oh, and actually, let me show you all one more thing before we write this function, which is that if we were to look at our cargo imports, these dependencies should look very familiar, right? These are like standard CosmWasm STD dependencies. The only difference is we're using this package, which is like the secret CosmWasm package, the secret CosmWasm storage package, and secret toolkit storage. And this is what allows us to actually receive this random number. All right. And so the way this works is like, if we were to go into this environment variable, what makes secret different, there's many things that make it different, right? But part of this customizable privacy is that in the environment itself, this is where the random number is actually being stored. So if we go into the environment and then we go to the block info, we look at that. This is like standard CosmWasm stuff, right? Like the height. But what we also have the time, the chain ID, this is all standard CosmWasm. But what's different about secret network is this is where the random number is actually coming from. It's coming from the block. And the way this works at a high level is that secret, like other Cosmos chains, is like uses Tendermint consensus. And part of Tendermint involves a pre-vote phase from nodes. And during that pre-vote phase is where this random number is cryptographically injected into the block. And that all happens within the transaction execution environment that we spoke about earlier. If that doesn't make any sense, don't worry. I just want you to have that high level understanding, but don't worry if that doesn't make sense, because I'm going to show you now how you actually like implement that in a function. So let's do this. So we're just going to implement this try-flip function. So all that we need to do is access the environment variable, because that's where the random number is generated, right? So first, we just got to load our storage and be able to update it. And anyone who's on the call, like if this is too, like if this is more than what you were looking for this demo, let me know. Because I was like ready to like jump in and do a full fledged. What's that?
I think it's perfect.
Okay, great. Okay, so this is just kind of basic CosmWasm boilerplate stuff, just making sure that we're able to access either a result or a contract error. Let's see. Okay. So we create this coin flip variable. And this is the magic, right? It's because during the pre-vote phase of Tendermint, that's where the random seed is injected. Then the block is where we pull the random number from. And so you can just use this code basically for any kind of like randomness that you want to implement into your app. And the way you receive the random number is just with this environment.block.random variable. And then we just need to unwrap it. And if anybody has like any questions about this or wants to like dive into the code further, all of this is going to be linked in the resources in that Google presentation. Okay, and this modulo is what allows us to take this random variable from the blockchain, from the block, and then make it either a 0 or 1. That's all we want to do. And then we just got to update the state of our contract with this new number because we instantiate it with a different number. Okay. And then we just need to unwrap this. I think, make sure I have everything in here. What isn't like about this? If I can't figure this out in T-minus 5 seconds. Oh, it's this. Is that what it is? Oh, there we go. We had one additional parenthetical. Okay. So this is literally all we need, right? This single line of code is where we're able to take this random number from the block info and then use that to then create any sort of logic that we want in our smart contract. So let me just see this. We should be able to compile this. Let's just see. So I'm just running a basic WASM compilation script. And if it throws an error, because we just wrote some of this code live, we're not going to worry about it, but it would be kind of cool just to show you. All right, nice. So we just compiled this code, right? And again, very simple. It's all happening in this one line. And I also, if you're new to developing in the Cosmos, I want to just show you how easy it is to use secret.js to upload and instantiate your smart contract actually on the blockchain. So we're taking the smart contract now. We just compiled it. And now we're just going to upload it to secret testnet and then showcase that we can actually return this random number that gives us either 0 or 1 based on the logic we just implemented. So I already wrote all this out because I know we have limited time and I don't want to waste anybody's time. But this code will all be live for anybody who wants to go back and look at exactly how to do this. All right, so I'm just going to run this upload script. And let me just make sure I don't have any other functions commented. Cool. And if our logic is correct in the contract, it shouldn't give us any issues. All right, so it returns a code ID and a contract hash. And if maybe you've developed on another Cosmos chain and not secret, what this contract hash might look a little bit different to you. That's just specific to secret and the way things interact with the TEE. It's another reason I want to do this, just in case there's any idiosyncrasies that are new to you guys. Okay, so now we're just going to instantiate this smart contract that we just uploaded using this code ID and contract hash. So this is our code ID. This is our contract code hash. And then this should return a contract address to us. Okay. Great. And yeah, see, so we're just using like the sender's wallet address, the code hash, and we're instantiating it with an initial flip value, which in this case was just 1. But it really doesn't matter because as soon as we call the flip function, it's just going to replace this with either 0 or 1 based on the logic we implemented. All right, let's instantiate the contract. And this is now the smart contract that we have access to. So this is our contract address. And now if we query this smart contract address, right, what it should return is this flip. And it should be 1 because that's the number we instantiated it with. But then once we call execute message, once we call flip, it should change it to either 0 or 1. And we might have to do it a few times in case it keeps, repeating the same number over and over again because of the pesky law of large numbers. So let's just query the flip very quickly. Make sure that it returns 1. All right, there we go. And then let's execute this flip message. So literally what we're doing here is we're just executing the smart contract using secret.js. We have a sender, which is the wallet address. We have the contract address, which we just had returned to us from our instantiation script. And then we just have this basic flip message. So now we're going to call this message. All right, looks like it was successful. Okay, we're going to query it. And we're going to hope it went to 0, but we have a 50-50 chance because what we're working with here, people, is verifiable true randomness. Hey, all right, first try. Look at that, beautiful. Okay, so hopefully this was informational, educational, and maybe even inspiring for you cosmonauts across the cosmos. I guess I'll open it up to questions now. If anybody has any questions or if anything else can be explained in more detail, I'd love to do that.
Well, in the chat, someone was asking if they changed 2 to a 6, if that would get 0 for 5 reply, but I don't think that would apply on how you created this function.
Oh, so they're just asking about the smart contract logic with the modulo?
Yeah, the question is, if you replace that 2 with a 6, could you get 0 to 5?
Yeah, okay, great question. So let me just share my screen one more time. Share screen. Give me 1 second. All right, we should be sharing Chrome again. So I just want to go back to this lottery dApp and show the source code for this. So this was fun for me because it was just taking, like, my first experience with this secret VRF was designing the coin flip tutorial, right? And then from there, I wanted to see if I could do exactly what this person who's asking this question is saying, is like, can I return a different number based on different smart contract logic? And so if you want to see what that logic would look like, this is just the logic for the smart contract that returns a number between 1 and 1 million. So like, I don't know if you guys can see this, but this is just an example of another implementation if you want to use the random number to do something different. So here I am just taking the random binary that's returned from the block, cloning it, converting it to bytes, and unwrapping it, and then using that to create this number between 1 and 1 million. And yeah, and here's this actual like spin logic for between 1 and 1 million. But basically, yeah, you can do whatever you want with this random binary and just use that as your seed for randomness in your smart contract.
That is awesome. Another question was, well, yeah, if the presentation is going to be shared, and we will be sharing it in the official hackathon site. Any other questions? Also, if anyone has problems deploying to Akash or are new to it, join our Discord. We'll be glad to help. And
great. Or one more thing I want to share just while I'm thinking about this is that there's a new upgrade coming to Secret Network very soon, which is going to introduce IBC hooks. This is Asaf, by the way. Everybody should follow Asaf on Twitter. He's one of Secret's core developers and he's brilliant. And what IBC is going to allow is a lot of amazing things, but one of the super cool things is that like general message passing is going to be possible on Secret Network, which means that like, because Axelar GMP uses IBC hooks to enable passing between Cosmos and Ethereum. So basically what this means is that like Ethereum contracts are now going to be able to call Secret contracts. And that means that like Secret can act as like a layer 2 for Ethereum smart contracts and provide a new layer of customizable privacy that wasn't possible on the EVM previously. And it also means probably that message passing between Akash and Secret will be that much easier. So all of this kind of stuff is going to be implemented in the docs for Secret very soon. But I just want to put that out there to kind of get that seed in everyone's mind, because there's really exciting things on the horizon of the cosmos.
For sure. Thank you for sharing that. It's gonna be amazing when that happens. So many possibilities.
Yeah, there's a question from YouTube live stream. Can we get a link to the presentation or yeah, so I think we will upload the presentation today later on our YouTube channel, so you can save it for later. And another question will be, if you replace that 2 with a 6, could you get a 0.5?
That one Sean already answered.
Yeah. Awesome. Cool. I think that should be all the questions, I assume. And if there's no more questions, I think we can wrap up here. Definitely appreciate, Sean, your time and efforts for this workshop. I think the whole process looks very smooth. And we will add those materials later on the hackathon page so that everyone can have access to it. Cool. That'll be all. Thank you very much, Sean, again, and also Rodri.
Amazing. Yeah, thank you so much for having me, everybody. Wonderful to meet you, and yeah, really looking forward to see what all the developers build. It's exciting.
Yeah.
Can't wait to see how it's used.
All right.
Awesome.
Thanks, everyone.
Thanks, everyone.
Bye.
Have a good day. Cheers. Bye.